Of all the branches of science, there's none quite like meteorology. Other disciplines, such as chemistry and biology, must have indoor spaces to conduct their experiments. While this is also true in meteorology, a lot of what we know in the field actually comes from outdoor observations. Many of these observations are taken from stations like the one behind me.
While there are national weather stations found all throughout the country, some states have smaller, more frequent weather stations that make up a mesonet. Meso meaning middle, and net meaning network. The UGA weather network consists of stations located at many points throughout the state of Georgia. This gives meteorologists a clearer view of the current weather conditions, as opposed to more sparse airport data. Each station is equipped with several tools used to measure valuable climate variables. Starting up top, one can see the anemometer, consisting of 3 spokes and cups attached to the ends, which measure the wind speed at any given time. Alongside is the wind vane, which determines the wind's direction. From these instruments, we can figure out what the maximum winds were in any 24-hour period, as well as when and where they came from. Next is the thermometer and relative humidity sensor. The thermometer tells us the temperature, but in order to get the most accurate reading of the air temperature, it is enclosed in special housing, which is open enough to allow air to mix in, but shielded from the sun so that it doesn't heat up the sensor directly. It is also painted white to minimize the amount of solar rays it absorbs and avoid false temperature readings. The relative humidity sensor tells us how much moisture is in the air. Although one can naturally tell if the air is humid or not, obtaining exact measurements is important for accurate weather prediction. Near the surface, we find the rain gauges. These measure the quantity of liquid precipitation that falls at a particular location. You may have noticed there are 2 different gauges. The open design can sometimes allow debris to fall into or obstruct the gauge, resulting in an inaccurate measurement. Having 2 gauges is important, especially in the event that one of the gauges fails to get an accurate reading. Because the Georgia mesonet is used mainly for agriculture, it also has soil sensors, letting us know how saturated the soil is, as well as its temperature. This particular station gives us soil temperature and moisture readings at 2-inch, 4-inch, and 8-inch soil depths. This information is very important, especially in the spring when farmers are just beginning to plant their crops. This instrument is called a pyranometer. It measures how much sunlight is reaching perpendicular to the ground. Although it will change along with the seasons, it is useful to know how much solar radiation is being received at the surface, as this is often impacted by cloud cover, and can be valuable information for climate research. To power the many instruments in each station, a battery and solar panel are used. The station will receive energy from the sun via the solar panel during the daytime, and any excess energy is stored in the battery, which powers the sensors at night or in cloudy conditions. Last is the data logger, which stores all the data collected by the sensors. Here, data is stored as a hard copy. This serves as a backup in case the real-time transmission of data is interrupted and lost. While mesonets may differ from region to region, these instruments measure crucial variables to provide surface observations in real time.
All of this data is very important, especially in real time, because what happens today is a very good indicator of what could happen tomorrow.